Guys, this is Gurneet. In today's video, we are going to take a look at linear regression in machine learning. So let's get started. What is linear regression? So a linear regression analysis is used to predict the value of a variable based on the value of another variable. Right, so the variable that we want to predict the value is called the dependent variable, while the variable that we are going to use to predict the another variable's value is called the independent variable. Right, so a linear regression algorithm, it shows a linear regression relationship between the independent variable and a dependent variable. Right, so that is called a linear regression. So now, since the linear regression shows a linear relationship, it means that we have to find out how the value of the dependent variable is changing according to the value of the independent variable. Right, coming to our next slide. So now mathematically we can represent a linear regression line as y is equal to a naught plus a1x plus error. So we must be you must be familiar with the equation of line, which is y is equal to mx plus c. So it's the same thing. So we have y, which is the dependent variable, or we can say the target variable. Then we have a naught, which is the intercept of the line, right? And then we have a1, which is the linear regression coefficient, and then x is our independent variable, or we can say the predictor variable, and e, this is our random error. Right, so as you can see in the graph as well, the y axis shows the dependent variable, right, and the x-axis shows the independent variables, and this is the line of regression, this black, and these are our data points. Right, now types of linear regression. So now we have two types of linear regression: simple linear regression and multiple linear regression. Right, now the only difference between the two is that if a single independent variable is used to predict the value of a numerical dependent variable, so that means that if a single independent variable is used to predict the value of the dependent variable, then that is a this is a simple linear regression uh, algorithm, right? Then, but if instead of one single independent, I have more than one independent variables, right, to predict the value of the dependent variable, then that is called a multiple linear regression. This can be, you can see that in the diagram as well, that in this case we just have one independent variable, while in this case we have more than one independent variables. Right, now a linear regression line. So a linear regression line, what it does is it shows the relationship between the dependent and the independent variables, right? And it can be of two types, a positive and a negative. So if the dependent variable increases, so if the dependent variable increases and the independent variable on the x-axis also increases, right, so in that case the relationship is termed as the positive linear relationship, as you can see in the graph as well, that if the value of the independent variable increases on the, sorry, the dependent variable increases on the y-axis, and the value of the independent variable increases on the x-axis, so the line will go up. Right, so in this case this is the positive line of regression. And then we have a negative line linear relationship, which means that if the dependent variable decreases, right, so if the dependent variable decreases on the y-axis and the independent variable increases, then in that case the relationship is called the negative linear regression, linear relationship. Right, so as you can see that in this graph, the dependent variable is decreasing on the y-axis, while the independent variable is increasing on the x-axis. So the line of the line of the slope, it's going down. Right, so in this case the line of equation will be y is equal to a naught plus a1x. Right, but in this case it will be y is equal to minus a naught plus a1x. Right, so this is a positive line of regression, this is a negative line of regression. Now, finding the best fit line. So when we are working with linear regression, our focus remains within to find the best fit line. So the best fit line means the error between the predicted value and the actual value should be minimized. So the best fit line will have the least error. right? So now the cost function. So how do we find the best fit line? That we find out using a cost function. So the main function, the cost function, what it does is it helps us to figure out the best possible values for a0 and a1, right, which provides the best fit line for the data points, right? So now cost function, what it does is it optimizes the regression coefficients or weights and measures the how a so it measures how a linear regression model is performing, right? We can use the cost function to find the accuracy of the mapping function, right? So which maps the input variable to the output variable. Now this mapping function is known as the hypothesis function. So for linear regression, we use the mean squared error cost function. So what it is, basically it is the squared error occurred between the predicted values and the actual values. As you can see in the formula, yi is, this is the predicted, this is the actual value, and this is the predicted value. In a1 xy plus a0 is the predicted value, and this is our actual value. So this is a mean square, it is the average of squared error of predicted values minus and the actual values, right? So I hope this equation is clear. Now the residual. So the distance between the actual value and the predicted value is called the residual, right? So as you can see in the graph also, that these are the data points and this is our line of regression. So as you can see that the negative, this is a positive residual, which means that the data point, and this is the line of regression. So we have to find out the value of the this is the line of regression is our predicted value and the data point is our actual value. So the distance between it is the residual. So in this case it's the positive residual, and the one uh, over here is the negative residual, right? Now if the observed points are far, so now if the points are far from the regression line, then what happens is the residual will be high, right? And in that case the cost function will also be high. And if the scatter points or the data points are closer to the regression line, then in that case the residual will be small and hence the cost function will also be less, right? I hope this part is clear. Now coming up to our assumptions which are related to linear regression. So linear relationship between the first assumption is that there is a linear relationship between the features and the target. So linear regression, what it does is it assumes a linear relationship between the dependent and the independent variable, right? Then small or no multicollinearity between the features. So collinearity means that there is a high correlation between the features or the independent variables, right? So due to that, it's very difficult to find out the relationship between the predictor and the target variables, right? Or we can say that it's very difficult to determine which predictor which predictor value or variable is affecting the target variable, right? So the model assumes that there is either very small or no multicollinearity between the features. Then coming to the third, which is homoscedasticity assumption. So this is a situation when the error term is the same for all the values of the independent variables, right? With this, there should be no other pattern distribution of data in the scatter plot, right? Now, coming to normal distribution of error terms. So linear regression, what it does is it assumes that the error term should follow the normal distribution pattern. If error terms are not normally distributed, then what happens is the confidence intervals, when we have a graph, the confidence intervals will become either too wide or it will be too narrow, right? So which may cause difficulties in finding the coefficient values. So we can check the normal distribution using a QQ plot. If the plot shows a straight line without any deviation, then which that means that the error is normally distributed, right? Then we have no autocorrelations. So the linear regression model, it assumes no autocorrelation in error terms, right? Now if there will be any correlation in the error term, then it will drastically reduce the accuracy of the model. So autocorrelation usually occurs if there is a dependency between the residual errors, right? So these are some assumptions related to linear regression. Thanks for watching. I hope the linear regression in machine learning is clear.